See guys, fundamental arithmetic theorem, I was explaining this, but due to some technical problems, there was the interruptions in the period. Fundamental arithmetic theorem, I am just repeating the statement, every composite number can be expressed as a product of its prime factor. This is the revision of yesterday's lecture. So, you may see on the screen 24 has been factorized as 2 into 2 into 3 and 3. Further, 2 can be written as 2 raised to the power 3 into 3. Is that clear? So, these right sides written here the prime factors and the left side is a composite number. And here 24 has been factorized. You may see this. The left side numbers are said to be its prime factor, and the right side numbers you may see these are the multiples. It means these can divide the number 24. All type of multiples also here. 2, 2, 3, 3, 3. These are its prime factors. Okay, and the structure I have drawn here the factor tree. This is factor tree. You may understand it. Factor tree. This is the first time when in the 10th class a student hears this word factor tree. And furthermore also 54 is equal to 2 into 3 into 3 is equal to, furthermore 2 into 3 times 3 together has been taken here. This you may see these all is the factor, these all are the prime factorization. Here 54 also has been factorized as 2 into 3 into 3 into 3 right now. So, I written here this as 2 into 10 to the power 3. The same thing is saying here. This is not a new thing. All people know this, the factorization, but it doesn't know what is the application and why do I doing so exactly. So, for understanding this, I will ask one question. If I would say you whether yes, whether could 54 be divisible by 6? So, can you answer me for that? Can 6 divide 54? So, easily you can speak here, but because you know the table of 54. But if I will select an example that is from your NCERT textbook, you may say this is like that. This is the prime factorization of that 32,760 before you this. You may see. So, if I will ask this question whether 32,760 is divisible by 35, so we will take time 2. How can we think that 35? Yes, obviously 35 is made up of 5 and 7, but 35 can divide 32,760. So, yes, easily you can predict the answer here. Look, in the prime factorization of this number, 5 and 7 are existing. 5 and 7 together making 35. So, easily you can speak yes, 35 is dividing the number 32,760. So, the first application you understood here, simply factorization is the splitting any composite number, any numbers in the small and we can say atomic type numbers, means further they cannot be broken. Is that clear? Their unit cannot be broken here. So, this is the prime factorization. Is that clear? So, prime factorization actually helps you to understand it's a prime, it's a consistingness is what what it's compositing, what it's made up of. This is the basic concept here. Just like a question you can understand here. That question in the yesterday lecture I gave you. Consider the number 4 raised to the power n, where n is natural. Check whether there is any value of n for which 4 raised to the power n ends with the digit 0. First, before starting this solution, I want to raise your confidence. So much language has been written here this, so it's not necessary write down to so much language as answer solution. Okay, before solving this, you have to understand and write answer in your own word. Okay, so what the questionnaire is saying, first try to understand. Before solving, you have to understand clearly the questions saying what the question exactly speaking you, right? So it's saying 4 raised to the power n. N is some natural. He is saying that if 4 raised to the power n will be extend for any numbers. So, is there any number n existing for that 4 raised to the power that number will end at 0? I am just explaining what exactly this question is saying right now. Have a look this. Just like 4 raised to the power n. Is that clear? 4 suppose n is 1. So, this is 4. Suppose 4 raised to the power 2. So, what it is 16. Similarly, 4 raised to the power 3, it is 64. Suppose 4 raised to the power 4, it is what will here 256 and 4 raised to the power 5 furthermore also here. So, what will it is 10 0 24 something else like that 4 6 are 24 4 5 20 22 and 4 to the 8 to 10 furthermore also can be taken as this right now. So, we are increasing this and here 1, here 2, here 3, here 4, here 5 something else. The same thing he is saying that. What the same thing he is saying that? He is saying that if I will take 4 raised to the power n, since 4 raised to the power, is that clear? So, 4 raised to the power n, is there any n existing for that number? If we will obtain or compose it, then it will end at 0. So, ending at 0 number, there are the two things. First is the value of n, and second the number coming after putting the value of n. Okay, and the third thing is also there. The number that will come is divisibility by 5. It's saying here. Please check this again on the question here. Digit 0, sorry, digit 0. So, a number that give me some number ending at 0 here. Yes, some number like the 10 ending at 0 and 20 also ending at 0 and 30 also, 100 also can you speak here this. Many numbers are there which are ending at 0. I have taken here the 2 digit and 3 digit numbers, but some any example also can be there. It's ending at 0. So, you see the factorization, yes, 2 into 5, is that clear? And its factorization is what here 2 into 2 into 5, you may see this, okay, and this is also here 2 into 3 into 5. So, you may see what is common in them, please tell me, sorry. Where we reached here. So, listen here guys, what is that 2 into further I am writing it 2 into 3 into 30 is also there, this factorization 2 into 3 into 5 is also there. Furthermore, where the examples go in here, okay, like that 20 and 2 into 2 into 4 5 and 10 also 2 into 5 and 30 also 2 into 2 into 3 into 5, is that clear? So, you may see the numbers are ending at 0. Okay. So, if the number ending at 0, what is the common in them all? 2 and 5, you may see the pattern 5 2 at least 1 2 is occurring in all factorization, and 5 is also you may also give an example by yourself. Okay, you write spoke here this 60, factorize it 2 into what next is 3 into 5, is that clear? You may say this at least once 2 occurring here and 5 is also occurring. It means that any number which is ending at 0, its factorization must include 2 and 5 as a prime factor, right guys, right now. So, you have concluded here the number which is ending at 0 must have 2 and 5 as a prime factor. Okay. So, please repeat the question again. The questioner is asking, consider the number 4 raised to the power n where n is natural, check whether there is any value of n for which 4n 4 raised to the power n ends with the digit 0. This we are to. So, before solving the question, we will factorize it, we will inspect it, and its factorization 2 into 2, and here we have written n, is that clear? So, we will see that the prime factorization of 4 does not include 2 and 5 as a prime factor, is that clear? So, what will happen to if you will increase the value of n up to any order like that 1 2 3 4 5 so and so 150, right? So, what would happen by increasing this? Its prime factorization will not change. How many factors are occurring in 4? 2 and 2 factors are occurring in 4, right now. These factor will continue, this factor will remain same. New factors, new terms will not come in the factorization of 4. Whereas the n will increase, so much value up to you can increase n, but its prime factorization will not change. So, what we can speak here? The prime factorization, here you will write the statement, since the prime factorization of 4 does not include, does not consist 2 and 5 as a prime factor, as prime factor, sorry, as prime factor, right now. Why? Because you may write down here a number ending at 0, ends at 0, ends at 0, has ends at 0, okay, ending at 0 also you can write here, has 2, 5 as a prime factor, and at 0, ending at 0, ends at 0, has a prime factor 2 and 5 there. So you can write here by what? Fundamental arithmetic theorem, by fundamental arithmetic theorem, what? Then yes, there is no value, there is no n, for which 4 raised to the power n ends at 0. That this is. So this is one application of fundamental arithmetic theorem. You can inspect here the prime factorization. If the prime factorization, because every prime factorization will make a composite number, and every composite number have its prime factorization. Is that way? You are not saying that it is divisible, but fundamental arithmetic theorem saying here. You have to give the reference of fundamental arithmetic theorem. You may see this. Now next question is there also. Example number 6. Find the LCM and SCF of 6 and 20 by the prime factorization method. So much solution is, and a bore sum appearance is here before you. So I am telling you prime factorization, to be concentrate over the word prime factorization, 6 and 20, SCF and LCM you have to find out here. So method of solving this here, simple it is. Solution, okay, since HCF of 20 and 6 you are to find out, and LCM of 20 and 6 also we are to find. Is that clear? And what the method is saying? Prime factorization. So do you know prime factorization? Okay, 20 goes in that 10 time, this goes in 5 time, 5 is there also, and it's 1. This again I am telling, this is factor tree, will remember please. So prime factorization 2 into 2 into 5. Again here LCM, 6 also prime factorization 2 and 3 it goes once, right? So 2 into 3. Now what is SCF? SCF we are to find out here. So sorry, this is not equal to, it is to be taken as here to find out this. Let this is the prime factorization, or also you may see here it is question mark we are to find. Okay, so it's a 20 prime factorization, or it's a 6 also. Now see what is common in them? Highest common factor. SCF means highest common factor. So what is highest? 2 is common in them? Yes, 2 is common in them. And 1 more 2 common? No. 5 common? No. So what is the most common in both? 2 is common here. So the highest SCF is what here? This number is said to be its SCF. Is that clear or not? So what you will write down here, the solution? Exactly. Therefore HCF of 20 and 6 is what here? 2. So you must know this. SCF, it is written as of, but written as within parenthesis the both number here. Similarly LCM I have to find out here. LCM of 20 and 6. What is LCM? LCM is least common. Least common, the meaning of least common means what? Least common means what? We will speak here. Least common, tell please. What is the least common concept? Least common means at one, it must be lay in any one of that. So see here, 2 is lying in that, obviously. So all factors to be written here. This 2 is at least 1. At least 1 means if it is in both, then you have to write once only. So 2 is common in both, I am telling this again. 2 is common in both 20 and 6. Okay, this 2 common in, okay. 3 is also in that. Okay, 5 is also in that. You may say this right now. So this is your what? This is your LCM. Now please write what is LCM. 2 2s are 4, 3 are 12, 5s are 60. 60 is your LCM. So you may say this, yes, I have taken how many all factors are there with 20 and 60. So I found here by the method, prime factorization method. Okay, this is your answer. You may write down answer. It is 2 and 60. The question is now complete. But for further information, we will inspect this solution. What the solution is here saying? Look, the solution is giving the prime factorization of 20 are 2, 2, 5, and prime factorization of 6 is 2 and 3 also. Is that clear? So I am writing these again. 20 factorization, 20 this is, okay, and 6 factorization 2 into 3, and I found here, see guys, it is these number you may see, I am talking about this, okay, this is, you may say that, okay, have a look at this, what is this? So you may see 2 into 2 into 2 into 3, 5, you could see here this, the green appearance of the letter, 2 3s are 6, 5s are 30. So I can understand here this. This is the what we can speak here. It's a 60 is coming here. This is LCM 60 is coming here, and 60. This is whole LCM. It is okay. So look here. This is the LCM. It is LCM. Okay. Let 2 into 2. This whole is called LCM. Is that clear? And where the SCF is there? I am doing an activity. SCF. SCF is what? 2 is XCF here. So this is SCF. 2 is also written here this as SCF. I am writing it. Means this LCM, I took here this, it's a LCM and here multiply by SCF. You may see this HCF. Okay. So what is that? So these 2 2s are 4. Okay. 4 3s are 12 and 12 2s are what next is? Again here 2 2s are 4, 4 2 2s are 4 and 4 5s are 20, you may see, and 3 2s are 6 also there. It means the all together numbers are here. We are compositing them 20 into 6. So what we conclude here? The conclusion with this is, if we will multiply both the number 20 into 6, their SCF and LCM is also get multiplied. What does this conclude? The conclusion is, the theorem also we can speak here, let A and B, AB are two positive numbers, two composite number, are two composite number, then what we can here, then 20, then A when multiplied by B, then what comes here? The SCF of AB and LCM of AB. This is the conclusion that we have drawn here with the help of our activity. Right now, means when the two numbers are multiplied together, their SCF and LCM is also get multiplied. And what is the application of this? Its application is, you can understand here in your textbook. Yes, see the exercise 1.2 in NCERT textbook. 1.2, express each number as a product of its prime factor. I think you can express it as prime factorization, or I would give you just as home assignment prime factorization by making the factor tree. Will remember you please. And if you cannot solve this question, however, ask me this on my WhatsApp number right now. Second question, find the LCM and SCF of following pair of integer and verify this LCF into LCM is equal to product of the two number. What is the verification of that here? The same verification you have to do as what I have done. That's like the biggest question I am solving, the third, 336 and 54. Okay, 336 and 54. 336 and 54. Solution number. Okay. Second, the third. Okay. Yes. 334. I'm just telling you again which question. This question, 336 and 54. Okay. 336. So prime factorization, since the prime factorization of 336 and 54. What is the method of writing prime factorization? Very simple it is. 336 factor tree I am making here. 2 1 is 2. What's left here? 12, 2 6 are, and again 2 8s are. 2 goes in that, how many? 8 times, and it's 4 time, again 2, 4 time and 2 time, again 2, 2 time and 1 time, again 3, 7 time, again 7, and it's a ones, right? The left side of the prime and the right side are multiple. 54 also there. 2 goes in that, 27 coming here. So 3 goes now in 27, 9 coming here. Again 3 goes, 9 coming here. Again 3 goes, 1 is there. Right now, so 3 3s are 9, 9 3 are 27, 2s are 54 is there. So it's a prime factorization. You may see this. The prime factorization is there. I can write the prime factorization in the next. Please bring this. Okay. So in the next, we are just doing this. Okay. You may see this. The prime factorization. Okay. Have a look. So what is that? How many times 2 are occurring here? 1. Okay. 1 2 3 4, 4 times 2. 2 into 2 into 2 into 2. 3 into 7. And 2 into 3 into 3 into 3. This is that. Now we are to find out what? SCF and LCM, and we are to verify this also. So it's a simple, it is verifications has to be done here. Find SCF of 336 and 54 is equal to, what is common in them? You may say this, 2 common in that. Okay, 2 written I have, and one more 2, no. 3 is common in that, yes, 3 I have written. One more 7, no. Is that clear? It's sufficient, it is, means 6 is SCF right now. Now we are to write down the LCM. It's LCM of 336 and 54. Okay, what is that here? LCM minimum, at least it must be, the factor must be common, at least 1. 1 means 2 is there, both, yes, 1 time you have to write 2 here, but 3 not here, so 2 will write down here, 3 will also write here. Now 2 here, 3 here, again 2 will write here, and 3 is also there. So what we can speak here, this pairing. And another method I also told you for finding the LCM, that in the 5th or 4th class you studied this, all right. You have just make the pairing it is that clear or not? I am telling this LCM finding method here, 36 and what next is 54. This LCM method is there, 2 goes in both, that is right now. So this is the method of finding LCM, clear? 2 common in both, 2 3 not common, 2 into 3 both, 2 again, 2 is there, then 3 is also there. If you are feeling the difficulty some in solving this, then you can do the method again here. Right now 2 goes in that, once what is coming here, 6 are 12 and 8 is, and it's a 27. Again 2, no, it's going 2 only, right? 2 8s are 16, 2 8 4, and what is that? 27. Repeat as same as it is. Again 2, it goes by, 4s are and 2s are, and it is what here? Again same it is. Again 2 it will go here. Again what will come? It is 21. It will come here, 27. Now it will go by, both will go by 3, and then later further. Understood you? Further you will solve this. So occurring both in, and 2 into 3 and 2 into 3 again, and 2 into 3 again right now. So first you have to write a common factors, it is 3 is occurring in both, exactly. First you have to write common factors, then later non-commons for your easy understanding. Okay, what is common in them? Tell please. So this is common and this is common. Okay, so 2 into 3 we wrote. Now what is not uncommon? It is, so this 2 and the other 2 also here, this 2 this 2, 3 2s are here and 2 3s are here, 2 3s and 7 also. Okay. So, here LCM is there. Okay. You may write down this in detail in very clear manner, 2 into 3. So, listen here, order is to be followed here, 2 2 2 2, how many times 2 is there, 2 1 2 3 4, 4 times 2 occurring, and 3 how many times occurring, 1 2 3 times this occurring, and it's 7 also. This is LCM of the number. Clear? Now, we have to test the result SCF and LCM is to be multiplied here. So, therefore, testing it is 336 multiplied by 54, okay, is equal to LCM and SCF. So, what is their multiplication? Here you will do the multiplication. You will do the multiplication. What is your multiplication? Your multiplication is what I think 36, and very rough work you can do here, but I am telling the method of solving. Multiplication means what? 54, this is to multiply here, 4 6 are 24. The simple method that you follow in 4 6 24, 4 3 are 12, 4 3 are 12, again here 13. Clear? 5 6 are 30, 5 3 are 15, 18, 5 3 are 15, and 1 16. Again what is here? 4, it's 4, it's what? 8 3 11, it's what? 8, and what is coming here? It's coming, it is I think 1 8 1 4 4. This is the number now coming after multiplication. And what is to do here after multiplication? What is to be done? It's very simple. It is you need to factorize it. This is one way. The other way also, you don't multiply this. Okay, simple it is. I am telling this. What is the number? 1 1. Here is also there. What coming? 2 into the LCM. You need to multiply their LCM of 336 and 54 multiply by HCF of 336 and 54. So, what is their multiplication? 2 into what next is 2 into SCF is what? 2 into 3, this is SCF, and LCM is what? 2. So, I think 2 raised to the power 4, 3 raised to the power 3, and 7 also there. This is the multiplication of both, and we have to bring. So, exactly you may see it's a prime factorization. After that you will multiply all here together, and what the number is coming here, and here also is to be multiplied, the number you brought here just previously. Here write the number what is coming, here write the number, or what is if coming, it is left hand side is equal to right hand side. Okay. So, verified here, it's verified, right. This is a simple method of that. Clear or not? Here you will write the composition of there. Please go to the NCERT textbook. Now, this is it. You seen that these are the very easy question, but not easy sum. Things are easy, but it's become easy when you appreciate them, when you attend them. Okay. See the question number 3 also. Find the LCM and SCF of the following integer by applying the prime factorization method. I hope you can solve. But sir, it's a question, new type question. 3 number have been given here. 12, 15, 21. Is that clear? These numbers have been given. So, for 3 number, how can we find out LCM? Simply, what you have done for the 2, the same you have to do for 3 numbers. Is that clear? I hope you can solve this LCM and SCF finding of 3 numbers. However, if you have any problem, please ask me and write on my WhatsApp number, right? And 4th question, given that SCF of 306 and 657 9, find LCM. Yes, you have to follow the same 336 657. 336 solution. Yes, what is to find out? 3 SCF, since given SCF of what SCF is giving here? Here that is 336. We are to find out LCM, okay, and SCF is given 336 657. 336 657 is what given, and you are to find out LCM 336 and 657. This is to find out question mark. Okay. So, what method you will imply? Since A into B is equal to LCF of AB and into LCM of AB. This is 2. Okay, these two numbers are there also, the two numbers also there. Okay, write the left hand right hand side. Can you solve this or not? Here you will write 36 and here you will write 657 is equal to SCF, I think given. What is SCF given there? Yeah, it's 9. The SCF is SCF is 9. Write down your 9 into LCM AB. From this, simply you have to transfer it. So it's a 336 and 657 divided by 9 is equal to LCM of A and B. Can you divide it further? Yes, we can divide it and obtain answer here. Is that clear? This is simple to have a look the next. Question number 5. Check whether 6 raised to the power n ended with 0. Yes, you have got, remember here the questions based on the fundamental arithmetic theorem. This is your home assignment. I will just check this. After solving this, let me send a solving report on my WhatsApp number, and you can ask me if there is doubt. Now question number 6. Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 are a composite number. They are composite number. Why they are composite? Think it. So some student just multiply them and to solve. Yes, a composite number achieved here. No, this is not method of solving. 7 into 11 into 13 plus 13. 7 into 11. Solution number 5. 7, since 7 into 11 into 13 plus 13 is equal to, we have to prove this is a composite number or not. This is composite number. Okay, so some student does this with how does they do with how they do with this question here. 7 into 11 into 13, they simply multiply them and write a composite number. No, it's not here. You may see this is the two term, these are the two terms here according to algebra. It's a one term and it's one term. Term means what? After addition, every terms are here. One term, two term, three terms, means addition makes the term here. Clear or not, guys? Yes. So how many terms are there? Two terms are here. What is common in both the terms? What is common? 13. So take 13 common. What's left here? 7 into 11 plus 1. Now again, what is to do here? It's a 13. 17, 11 7 is 77 plus 1. Furthermore, 13 into what is 78. So please observe it. What is 13? Sir, it's a number. No, regarding factorization and composition is prime factor. And what is 78? Sir, this is composite, obviously. So 78 is to be written as prime factor what? 2, 3 times it goes, and 9 again 3 times it goes, 1 is and 3 is. Okay, now further it cannot go. So further it can be written as a 13 into 2 into 3 into 13. Is that clear? That is 2 into 3 into 13 raised to the power 2. What does come here? Sir, it's factorization. No. Yeah. Yes, yeah, I saying factorization. Right? Now, what type of factorization this is? Prime factorization. So recall the concept of fundamental arithmetic here. So you will write here, since this is a prime factorization. This is a prime factorization. This is a prime factorization. So by fundamental arithmetic, fundamental arithmetic theorem, it will form a composite number. It will form a composite number. It will form a, means we are not saying this is a composite number. By fundamental arithmetic theorem, it will form a composite number. So, second part of the question you can solve, I think, like this is second part of 6 into 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite number. Can you solve this or not? Okay, I will expect to solve this by, and the question number 7 is also there, your home assignment. So, have you remember this? Got you remember this your assignment here? The question 1 part of the 6 and the 7 is also your home assignment, and also I gave you the question first as. Please will appreciate, and if you have any doubt, then I will tell you this question again. Is that clear, guys? Be honest, appreciate your work, and be independent. You will be able to understand mathematical very clearly. Is that clear? Things are simple, but they are not actually simple in doing. Right, guys? Thank you very much. Have a nice day.